Welcome to GATE 2021 model questions on control systems. Today's our topic is root laws technique. Let us see the question number 1. The open loop transfer function of a negative feedback control system is been given. GH is equals to K into S plus 2 into S plus 3 by S square into S plus 1. And the root laws diagram of negative feedback control system has K varying from 0 to infinity. These are the options shown here. Let us go for the solution. If we see this type of model question, that is K by S square is there, then S plus 2 divided by S plus 1 into S plus 3. This model question is actually independent of your numerical data, which we will be explaining using frequency domain method. Since there is in the open loop transfer function, since there are two poles are lying at origin. If two poles are lying at origin, what is the phase angle it will provide is K by j omega whole square will be minus 180 degrees. The remaining poles and zeros will be adding only in the left half of this plane, and they'll make only tan inverse of omega by poles or tan inverse of omega by zeros, like that only they'll make it. Hence, for zero frequency, what we can expect the phase angle when you have two poles lying at origin is obviously minus 180 degrees. This is your explain. We added a two poles at origin, then we will definitely get at zero frequency, the phase angle value will be minus 180 degrees. Now, in this example, now we'll be adding zeros and poles. First, if you observe in this question, they are adding a pole at first minus 1. Whenever you add a pole, not only minus 1, you can take some minus 3, minus 10 or minus a also. Whenever we add a pole, the phase starts to decrease. Now obviously it reaches for infinite frequency. If you add only one pole means what angle you get at infinite frequencies? Minus 180, minus 90, minus 270 will get it. After that they are adding again a 0 at minus 2. The system actually will call it as a lag system. First adding a pole, next adding a 0. When you add again a 0, the phase starts to increases and reaches to where is minus 180 degrees only for infinite frequency. Now if you want to increase this phase again, you have to add a 0 once again. That 0 need not to be here, they are given as minus 3, it can be minus 5, minus 7, anything. If you add one more 0, definitely this phase starts to increase, and what angle you get at infinite frequency is minus 90 degrees. So this is a lag as well as next lead. But because one more pole where it located is obviously at infinity, 0 and pole means it's a lag lead system. First S plus 2 by S plus 1 is a lag system. Then again adding a 0 means phase increase. This itself will tell that definitely for a finite frequency, the phase plot will cut minus 180 degrees. That frequency only will name it as phase crossover frequency. I can write the phase angle of your given open loop transfer function also like this: minus tan inverse of omega plus tan inverse of omega by 2 plus tan inverse of omega by 3. In this phase angle, you substitute omega equal to 0, definitely will get angle as minus 180 degrees. If you substitute omega equal to infinity, you'll get minus 180, minus 90, plus 90, plus 90 will give minus 90 degrees. But how the phase will be there is phase plot is with this lag lead analysis only we can analyze it. That is, first adding a pole makes the phase to decrease, again adding a 0 phase increase, again adding a 0 phase increase. That's why definitely for a finite frequency you'll get phase angle minus 180, that is omega PC. But if omega PC exists, means compulsory the root locus will cut the imaginary axis where is at plus or minus j omega PC itself. That you should know it. That for this simple question we can find using RH criterion also, is it root laws will cut imaginary axis or not. But it is a standard model question where by just adding poles and zeros lag lead cases we can analyze this question. Let us go to the root laws diagram. What are the open loop poles? They are given is double pole at origin and one more pole is at minus 1. Next we have two zeros, minus 2 and minus 3. At k equal to 0, the three roots of the characteristic equation are open loop poles: 0, 0, minus 1. Infinite gain, they are open loop zeros. 2 are infinity, infinity. One more branch will varies infinity at an angle of 180 degrees. That is only we'll call it as asymptotic angle also. Now where the root loss lies on the real axis, obviously if you select any root between 0 to -1, on the right hand side the number of open loop poles and zeros is an even multiple. That's why root loss does not exist. And if you select any root between -1 to -2, on the right hand side the number of open loop poles and zeros are 3 odd multiple. Hence root loss lies on the real axis between -1 to -2. Hence we'll take that region. Next, what about between -2 to -3? On the right hand side, again we'll get an even multiple. Root loss does not exist on the real axis between -2 to -3. And what about -3 to -infinity is lies an odd number. You'll get it. Hence the root loss existence on the real axis we have find it out. Then what is the angle of departure of this pole is 180 degrees and reaches to this 0. For one root loss branch or one closed loop pole as k varying from 0 to infinity is -1 to -2. The remaining two closed loop poles will break away here and again they'll break in between -3 to -infinity, and one branch reaches to this 0, another branch terminates with 180 degrees. But whenever they break away, compulsory root loss will cut imaginary axis one time. That's what you should know it. Therefore, I'll show with a different color. For these two poles will break one breaks and they'll break in. Compulsory whenever they break away, they'll cut imaginary axis and that value will be definitely j omega pc only. They'll break away like this. And one more branch will be goes like this. For the two branches, one branch like this cutting imaginary axis here minus j omega pc cuts one time and they will break in here. After break-in, one branch reaches to this 0, another branch terminates in infinity with an angle of 180 degrees. Or one branch terminates infinity with an angle of 180 degrees. Another branch will reach us to that 0 minus 3 itself. As k tends to infinity. For the three roots of the CATS equation, where they are located, are three root closed branches. One root closed branch or one closed loop pole as k varying from 0 to infinity, this black color, -1 to -2. Another branch will break away and cuts imaginary axis for one gain, and then again comes to this 0 -3 itself. Another one will break away here and reaches to this, reaches to infinity with an angle of 180 degrees. So this is only your root locus diagram. Hence, your correct option is D. So this problem, please remember that it is independent of numerical. You'll have a double pole lying at origin, then adding a lag system, first adding a pole, next adding a 0, again adding a 0. The plot is fixed for us. Okay. Thank you. Any doubts you can post in the comment box.